Okay, so the first thing we're going to look at is E being irrational. Now, I don't actually know if you know this proof or not, and you just learned it yesterday, so it might not be all the details are in your mind, but how did it work? The proof that E is irrational.
So it's a proof by contradiction. So first you assume it's rational.
Okay, so assume E equals...
I think they called it A over N.
A over N?
N was the denominator.
Okay, I'll use the same letters, so maybe that'll help you remember exactly how things go. Assume E equals A over N, where these are integers, so it's like 2/3 or 1,000 over, whatever, 400 or something.
And because E is defined as the sum of 1 over the factorials, so the reciprocals of all the factorials from 0 to infinity.
Okay, right, this is the definition, or sorry, one of the definitions of E. Have you seen, do you remember this?
Yeah, this comes from the Taylor series for E at 0.
That's right, yeah. Yeah. So E is 1 plus 1 plus a half plus a 6. So, okay. So we know this is the definition of E, and we're going to assume that this ends up being a rational number. Okay?
Then they defined two other things. They defined X as the sum of the terms in E from start to 1 over N factorial.
Okay. So where N is the numerator or the denominator, sorry, in our what we assumed E was.
Mm-hmm.
Okay. And Y, so I'm having a hard time reaching through the tripod here. 1 over N plus 1 factorial plus 1 over N plus 2.
This is the rest of the terms.
Okay, out to infinity. So X is the first N terms, or I guess the first N plus 1 terms, and Y is the rest of them going out to infinity. Okay, and where N is defined here. Okay, what do we do now?
So what we do here is we prove that in this case X is an integer, or X times N factorial is an integer.
Okay, yeah, so we see that X plus Y is E by definition. And now we're going to multiply everything by N factorial.
Yeah.
Okay. So that's going to be, since E is A over N, if we multiply that by N factorial, why do we get an integer?
Because N factorial has a times N in it, and E is A over N, so the denominator will become 1.
Okay.
And
Factorials are just comprised of integers.
it will be A times N minus 1 factorial.
Okay, so try to figure out where to put this. So, okay, N factorial times E by assumption, by this assumption, is an integer.
Yep.
N factorial times X, I'll just do a bad thing and just rewrite over what I'm doing. Now, you've not seen this before, I don't think, or it's certainly not fresh in your mind. What can you say about N factorial times this sum?
Well, you know it's rational, right? Because you know this is rational, and you know that N is rational, and then you can say more than that because you know that N factorial is going to be, it's going to have a common factor with all the denominators because you have the numbers from 1 to N, and you have the numbers from 1 to N here. So you're going to get like N factorial, and then N factorial, and then N factorial divided by 2 factorial, and then N factorial divided by 3 factorial on the top all the way down to 1. So you get integers on the top because they cancel out the denominator, so this is an integer.
Okay, great. So this, now remember E is X plus Y, so N factorial times E is going to be N factorial times X plus N factorial times Y. So this is an integer, 2.
Yes.
Okay, so we have 2 integers, and now we just have to look at this. And this is where, this is the tricky part, but so what happens when I do N factorial times Y?
Let's see.
So I have N factorial times 1 over N plus 1 factorial, 1 over N plus 2 factorial. Sorry, I'm going to not make my N's all the same, but that's what I mean. Okay, so what does this equal?
Well, for the first term,
You gonna write it? Okay,
Yep.
great.
So for the first term, 1 over n plus 1 factorial times n factorial, this is 1 over n plus 1.
Okay, great.
Next term is going to become 1 over n plus 1 times n plus 2. The next term is 1 over n plus 1 times n plus 2 times n plus 3.
Yeah.
And this is going to continue.
Okay. So this is a series. Here, write plus dot 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 there. This is an infinite series, but it's difficult to make any sense out of this infinite series. So we don't know what to do. So we need an assumption here that's going to help us at least understand this series. And this is the trick in this calculation.
I mean, you know that all the terms are rational.
You know that all the terms are rational.
You could say that all the terms are less than 1.
They definitely are all less than 1.
But it's kind of difficult to sum up the terms.
You can't sum them up. Yeah, it's too hard.
It's not an arithmetic or geometric
Finding
series.
something that they're less than is the whole key. All the terms are less than a very simple series.
Well, let's see. So they're all less than, I guess, 1 over n. You could say. So maybe.
The first one's definitely less than 1 over n.
And then you multiply by things on the bottom. So you could say this series is less than 1 over n plus 1 over n plus 1 over n. Like that. Or maybe you could say 1 over n plus 1 over n plus 1 plus 1 over n plus 2.
1 over n maybe plus 1 over n squared, because you have these two things here. If
Yep.
you, they're still going to be.
Yeah, so 1 over n plus 1 over n plus 1 over n going out forever is going to become infinity. 1 over n plus 1 over n squared plus 1 over n cubed actually is really nice, because what is that?
That's a geometric series.
Yeah, so that's. I think if you start with 1, so you could. Yeah. So it's n times 1 plus 1 over n plus what we had before, which is n times 1 over 1 minus n. I think.
Well, that's going to be negative, because n's an integer and it's large, so...
No, it's 1 minus 1 over n, because
Yeah.
because n is
1 over n, yeah, 1 minus 1 over n.
Yeah.
Okay, so what is this?
So this is n times 1 over n minus 1 over n, so n times, it's n squared over n minus 1.
Yeah, now I don't know why you said this was n times this series. I don't think that's what you meant.
Well, or 1 over n. Oops, yeah.
Yeah.
So it's then that actually just makes it easier. It's 1 over n squared minus 1, or 1 over n minus 1.
Over n minus 1. Okay. Did you follow that?
Yeah.
Okay. So our y, n factorial times y, is, we don't know what it is, but we know it's less than 1 over n minus 1.
And then I guess we can say this is less than 1, so this can't possibly be an integer.
So we have integer equals integer plus not integer.
I think that's still on screen.
Okay.
Yep.
And what's the problem here?
This can't possibly be true. You have to have both of these parts be integers for this to work.
Yep.
So our assumption at the beginning that e was rational must have been wrong, because if e was rational, things break.
Yeah, so that's a really cool proof. Okay, very good. Let's go on to the next idea.